So now we need to prepare for our second homework assignment. Yeah. So after Wednesday's class, I will assign you a second homework assignment. Because we need the material from today and Wednesday's class to do the second assignment. Yeah. Mainly, we need to understand some basic features for table. Yeah. So let's continue to understand table. Yeah. All right. So in our company database, so this is another example for the department definition. Yeah. Here you can see after we define a table, so this is, we add, oh, I need to change the pen color. Oh, yeah. All right. So then we add multiple constraints. Yeah. So this alter table department. So here you can see we add multiple constraints here. The first constraint, we add a primary key, denumber the primary key. Second, unique key, add unique key, dname. Yeah. All right. So although, so we know we can use the another way. So many people, they use the, for example, unique. You can add unique directly after that field name. Yeah, that's one. And you can also add this primary key clause directly after, at the end of the table definition, the field definition, the field description. Yeah. Yeah. And this way, because this way I use the export. Yeah. So in the PHP myadmin, PHP myadmin, this web application, inside this there are two features. One import feature, another export feature. Yeah. So because sometimes people want to move this database from the current server to another server, different location, another server, at different location. So usually we want to export the whole database, as in a large, relatively, if you have a lot of data, so relatively large database script, text file, it's a text file, all right? Our regular, the .SQL file that I uploaded, I give it to you, the same format, but we need to export it, So it could be a big text file, big long text file, depends on how large is your database. You export it, So this is because export, you need to use the auto generation feature from the MySQL, from the, not from the MySQL, from this PHP myadmin. PHP myadmin has that feature, auto generation feature. So then it uses the format. So this is the auto generation feature. Okay, yeah, standard format. Yeah, so, right, all right. That's the export. Okay, yeah. So yeah. Then import, another feature. So when you have a big database, now you want to install it on the current server. Yeah. Yeah. So then you use this import feature. Yeah. You click the import tab, so you upload that. Yeah. So here, let us imagine a relatively large text file. Yeah. Because when you have a large text file, then the import feature is much better. For small text file, then most people, they do not use the import feature, although they can, but they just use copy paste, right? So you use a text editor, you open that text file, then you copy paste, then you run. Yeah. So most people do it that way. Yeah. But for a relatively large, sometimes, yeah, I did some databases with hundreds of megabytes. Think about that size, hundreds of the data, only the text type data, several hundred megabytes. How large it is? Definitely, you don't want to do copy paste, right? Yeah, hundreds of megabytes. And nobody wants, because your buffer cannot hold that big data size. Then you have to use this import feature. Import, so no problem. The import, even the zip file, you can do because sometimes when you do export, you could choose the zip file. Yeah, because of the text file, there is another feature apply zip file on that text file. Yeah. So that zip file, you do not need to unzip it. Okay? Yeah. This import, you directly import from the zip file. Yeah. So that tool automatically unzip it, then execute the SQL commands in the script file. Yeah. All right. So here, so you have some background information. Yeah. Because in the real world situation, yeah, you need to use these features. Yeah. You need to have the background knowledge, control your data. Yeah. All right, next, base relations and the virtual relation. Base relation, base table. Yeah. Our regular tables, base relation. Virtual, the views. Yeah. So we learned last time. Yeah. Base relations or base tables. Yeah. So we use the command create table statement. Yeah. So we are already familiar with this command. Relation and its tuples are actually created and stored in physical storage. So for base tables, the data is physically stored on a hard drive. Yeah. All right. Virtual relations or views. Yeah. So we use the create view statement. Yeah. It may or may not correspond to an actual physical file. May or may not. So may not. The default is may not. Okay. The default is it's not stored physically. The default case. Yeah. But so if you really want to store the data physically, there is some good reason. Some good reason people want to, because the data generated very important, very useful, for example, in that situation, or used frequently. Yeah. Then you have good reason to store it. If the data generated, not just to use 1 or 2 times, so why you store it, right? Yeah. All right. contain the derived data. Yeah, we spend a lot of time, remember, study the derived data, the importance of derived data. Oh, all right, yeah. So that's the, the previous topic we complete. Then C.2, order property. Yeah, order property. I explained a little bit about order property, right? Remember? Yeah. So last time I talked about total order, partial order. Yeah. So here I can go a little faster. Yeah, because part of the things we have learned. Ordered or not for attributes and the tuples. Yeah. Attributes or columns, attributes in a base table considered to be ordered in the sequence. All right. So here, yeah, I mentioned that before, but here I may like to emphasize a little bit. Yeah. So this concept I mentioned before. Yeah, the meaning. So here I give a simple example. Yeah. That explain another time. Yeah. In a tuple, so here we're talking about the order, yeah, attributes order, okay? Yeah, so because when you talk about order concept, there are two different meanings. Yeah, two different meanings. Yeah. One is ordered, the other is unordered. Yeah. All right. Two cases. The first case, yeah, inside, yeah, so inside each, yeah, here I emphasize individual, okay, inside each tuple. Yeah. Here I use example. A1, A2, A3, AN, yeah. So then ordered, okay? Yeah, yeah. Because if you switch A1, A2, yeah, if you switch A1, we treat as a different tuple, okay? Yeah. If you, then different tuple, right? Yeah. So that's the first meaning. Yeah. Second meaning. Yeah. So yeah, we will see tuples. Yeah. Now we look at the outside tuples. Yeah. So we look at outside tuples. Yeah, not inside tuple. Each tuple. All right, yeah. So then we'll look at our data row by row, okay? Row by row. Each row has a tuple, right? So each row as a tuple, we do not change anything, okay? So we preserve the content of each row. Yeah. So each row, we keep the content, okay? Yeah, yeah. Do not touch it. Then we can consider orders. We can consider order of those tuples, right? Yeah, tuple 1, tuple 2. Yeah, so here I write T1, T2, T3, ... How about we swap T1, T2? Think about that. We can swap T1, T2, right? If you swap T1, T2, because in this situation, we consider they are unordered. Yeah, so this situation, unordered. If you swap tuples in this way, we treat it as the same table, okay? Same table. You do not get a new table, okay? Yeah. So you change the order in that way. A second way, so we treat it. So you have the same table. You do not get a new table. Yeah. So that's two different order meaning, understanding. Okay? All right. The tuples are not considered to be ordered. See? Yeah. The tuples. Yeah. But you treat each tuple as an element. Okay? Yeah. You don't look at the content inside the tuple. Okay? You treat the whole tuple as one object. One object. Then you rearrange these tuples. Okay? Not unordered. That's the meaning. Okay? So you need to understand the details like that. Details like that. Okay? Yeah? Yeah, because some people, if they do not understand the difference in this kind of details, yeah, you know, they do not separate inside individual tuples, outside individual tuples. So then they get confused. Yeah. Then they get confused. Yeah. All right. Yeah. So understanding elements inside tuple are ordered. Yeah. Inside. So those little a's. Yeah. Inside tuple. They are ordered. Okay. Yeah. Ordered. Another property. Allow duplicates. Right. Yeah. Allow duplicates. Duplicates allowed. Yeah. Okay. Yeah. Yeah. All right. When we treat the tuples as elements, they are unordered. Yeah. One tuple we treat as one element. Okay? Yeah. That one. Yeah. Yeah. That unordered. Yeah. So these two meanings. Yeah. All right. So we view a relation as a set of. Yeah. So here, be careful. Yeah. This careful. Yeah. So here, I want to update. So here, the last sentence. You should be very careful. Yeah. This set, when you talk about this set, you should be careful. Yeah. Oh, John, question?
I imagine that you're talking about don't confuse it with the technical term set, which means you can't include duplicates. In this
Right,
case.
exactly. Right. Yeah, so, right, exactly. So here I want to, because in our everyday life, when we talk about set, what's the meaning? When we say a set of objects, we say,
It would just mean a bunch of objects.
right. So that's why people may get confused, because in math we do not allow duplicates. Okay? In math we do not allow duplicates, but in our daily life we do not distinguish duplicates or not. Right? A set of objects, the same thing as a group of objects. Right? A group of objects. You know, if it duplicates, still a group of objects. Yeah. So that's why here you should be careful. Yeah. And if you want to use our rigorous set concept, this word should be replaced by a multiset. Because we know in a relation, duplicate tuples are allowed. Okay? And it's very common. Yeah, we allow duplicate tuples. So here, I want to write this out. Yeah, because this is another important point. Yeah, so you may have some quiz questions, homework assignment questions, test questions. I will check your understanding on this concept. Okay. Yeah. So here, let me clearly write it out. Allow. Duplicate. Yeah, so let me separate here. Okay, allow duplicate tuples. Yeah. All right. So so that's the that is, this rule is very needed in SQL. Yeah, in SQL. Yeah. We know in the original academic project, this probably is not allowed. Okay? Yeah. So those researchers, they do not allow this property. Yeah. But in the business world, this property is so important, so useful. So you have to take it. Yeah. in the business world. Yeah. Because later you will see many of our query results, we have the duplicate rows. Yeah, yeah, yeah. Otherwise, you get stuck, okay? You cannot handle the, real world business requirements. Yeah. All right, so let's move to next slide. Yeah, yeah, set, multi-set. Yeah, we already compared that before. Yeah, so we can go a little faster. There is some difference. Yeah, formal relational model. Yeah, SQL emphasizes real-world applications. Formal relational rigorous theory. Yeah, math. Yeah, based on the math concept. Yeah, we know. Yeah, when we go to the business world, we have to modify the original usage of the rigorous math concepts. Yeah. All right. View of tables or relations. So yeah. SQL allows a table have two or more tuples that are identical in their attribute values. Table multiset. Yeah. All right. In the formal relational model, a relation is required to be a set. Yeah. Mathematical type set. Yeah. No tuple is allowed to be repeated in a relation. Yeah. But this is too restrictive. Okay. Yeah. In business, yeah, you cannot adopt this rule in the business world. Yeah. Yeah. All right. Oh, yeah. So that's C.2. Yeah. Yeah. Because a lot of things we have learned before. Yeah. So here we just like a review. Here we just review. Yeah. All right. Then let's go to C.3, basic constraints. Yeah. Several simple constraints. Yeah. So we can define a primary key. Yeah. So that's a constraint. Primary key constraint. Yeah. All right. Use the primary key clause. Yeah. We define. Yeah. The primary key clause specifies one or more attributes. Here, one we can understand easily, right? But how about the small attribute case? More than one. Yeah. That's something we need to learn. Yeah. More than one. Think about it. Two or more attributes. So we use a group of attributes, multiple attributes, to define one primary key. Yeah. So here we need to understand this special situation. Yeah. Although the percentage relatively small. Yeah. So most of the cases you just use a single attribute to define primary key. But still there is some small, but you cannot ignore. Okay? Yeah. Some special cases you cannot ignore. Yeah. So you need to consider to use more than one attributes or fields. Yeah. Because attributes, that's the terminology in the formal relational model, right? In a business, people like to use fields, columns. Yeah, attributes, that's the, academia people, researchers, they like to use, those formal words. Yeah. That make up the primary key of a relation. Now, I need to focus on the small situation. How to? Yeah. For single, it's straightforward. Single case. Yeah. If a primary key has a single attribute, the clause can follow the attribute directly. Yeah. Right after that attribute or field declaration, you just add a primary key attribute. How about that? Yeah. Okay. Yeah. For example, yeah. SSN. Yeah. So this field, yeah, in our employee table, SSN. So then we define, data type, right? Yeah, varchar, certain number of characters up to. So then, other constraint. Yeah. After that, we just put this primary key clause. How about that? Yeah. Single attribute primary key. Yeah. Yeah. We append this primary key clause at the, after the declaration. Yeah. Yeah. That's simple. All right. All right. Can follow the attribute directly. All right. Example. Yeah. D number, int integer, then primary key. Yeah. That's straightforward. String. Yeah. Although you can do it at the end, after you declare all the fields at the end, you declare primary key parenthesis. In that way, you need to use, yeah. Actually, that way is the second way. Here we are talking about the first way. First, we append primary key clause right at the end of the field declaration. Yeah. First way. Second way, yeah. Yeah. Another form of primary key clause after. Yeah. So after our declaration of all the fields, yeah. Now we write the second way, because the second way can be applied to more than one rows. Yeah. First way you can only apply on a single row. Yeah. So the second way, a little more general. Yeah. You can apply on a single row. Oh, sorry. You can apply on a single field. You can also apply on multi fields. The second way. Yeah. So let's look at example. For single attribute primary key case, yeah, we just, inside parentheses, we include that single attribute name or field name. Yeah, straightforward. Yeah, all right. But that is after, okay? Yeah, after the declaration of all the fields. Yeah. Yeah. And for multi-case, we call it composite primary key, okay? Yeah. If you need more than one attributes or field names, fields, yeah. Later I will explain why more than one, okay? So here I hold that question a little bit, yeah, because I believe some of you may want to ask why we need more than one, right? Yeah. So I hold this question a little bit, yeah. So this type we call a composite primary key. Yeah, more than one fields used to define one primary key. Then the way to do it also straightforward. Inside parentheses, you use comma to separate different fields. Comma separated a list of fields. Comma separated way. Yeah, John?
Just to clarify, what we're saying here is that if you have a composite primary key, you always have to declare it after the primary key.
That's correct. That's correct. Yeah. Because, you use the first way, you have no way. How do you cover two different fields, right? Yeah, definitely. Yeah, definitely. So that's the reason. Yeah, that's the reason. Composite. Yeah. All right. Yeah. Yeah. But remember that alter table way, we can also use that alter table way. So this is, inside the table definition, we do this way. Okay. Yeah. Yeah. That's different because we have another way. Yeah. Alter table constraint declaration. In that way, we can also do it. Yeah. Exactly. Yeah. So the second way. Now, next, I need to explain why people need to use composite primary key. Yeah, that question. All right. Yeah. So like after I finish this order table way, okay, order table. Then because that's an important question, I need to answer. Okay. All right. So for the order table way course, you add. So add, yeah. But for composite, you just, composite primary key, you just, use that parenthesis. Inside parenthesis, you put more than one fields. Yeah, That simple. Okay, that's simple. Yeah. All right. Yeah. So then the last question. Yeah. First, let us understand what is the main purpose for us to use a primary key. Yeah. So why would you need to use a primary key, right? Yeah. Yeah. Let's start from this question. To identify the roles, right? Yeah. The main reason people use primary key to identify the roles. Otherwise, when we think about when you need to edit certain roles, how do you identify the roles? You need to select the correct role, right, to edit. You don't want to edit a wrong role, right? So the most convenient way, you use primary key to identify those roles. Yeah, that's the biggest reason people use primary keys. Okay. All right, then the next question. In order to identify the roles with primary keys, or with a primary key for one table, okay? Yeah, because one table you can only have at the most one primary key, right? Yeah, all right, at the most one primary key. Yeah, you can have a table you can have non-primary key, but you cannot have more than one primary keys. Yeah. All right, so think about, this time we need to go back, connect to our previous slide. Our previous slide says our tables are allowed to have duplicate rows, right? Our table are allowed to have duplicate rows. Think about when your tables have duplicate rows, how can you have primary key? You have no way to identify it, right? Because duplicate rows. You have no way. Two rows, duplicate rows, two rows, you can find two rows with the same value. That's duplicate rows. So no way to identify these two duplicate rows. So no primary key. Yeah. So that's the first situation. This way, no way. Even you use composite key, you cannot identify, right? Because duplicate, no matter how hard you try, you can never create an even composite primary key. No way to separate two duplicate rows. Yeah. Yeah. But here I want to talk about another situation. Yeah. No duplicate rows. Yeah. So in a table, we assume there are no duplicate rows in a table under that situation. Okay. So here, let me, because this question a little deeper than other questions. Yeah. The logic behind it a little deeper. Yeah. And usually I may create several concept questions in your homework assignments or tests. So I'm willing to expend a little more time to explain this concept. Okay, all right. So here I want to explain why a composite primary key is needed. Okay, this question I want to explain. All right, so this time I assume, so here I assume, so I write it out clearly, because then you can think about the logic. Assume that there is no duplicate row in a table. Okay? Yeah. So you know the meaning. I don't need to explain. Okay? Then my question. Okay? Then my question is this. All right, the question is, can we define a single field primary key this question. Yeah. I told you no duplicate rows. Okay. That means two rows, they always have different values. Okay. Two rows. Yeah. John?
Well, it seems to me like the easiest way to do it would be to just use arbitrary ID numbers that are connected to no particular individual. When a new entry gets added, an ID is automatically assigned that's unique. So even if a duplicate entry gets added,
Okay.
the ID number is
Good. All right.
It looks like the same two people. One of them is
All
ID
right.
11102, the other is 11103.
Yes. All right. Yeah. Nice. Yeah. Nice thinking. Yeah. Nice thinking. Yeah. But so this question is a different question. I will spend more time to get there. Yeah. That's a very important, actually important feature, very useful feature in MySQL. That probably I need to spend at least 10 minutes to explain that. Yeah. Yeah. You go ahead of me. Yeah. Yeah. But here, yeah. Still, let's answer this question first, because this is also important concept. So we have to have a good understanding. Then we move to that. So that's called auto increment primary key. Yeah. So I will talk about that. Auto increment. Yeah. That's a very important feature. Yeah. Yeah. I need to find some space to explain that concept. Yeah. All right. So here, yeah. Let me repeat this question. We already know in a given table there is no duplicate row. Okay? Yeah. Yeah. Whenever you pick two different rows, they have different values. They have different tuple values. So you know the meaning of tuple, okay? When we compare two tuples, the tuple values are different. Yeah. Yeah. All right? Yeah. All right. That's the meaning. The question is, in this table, can we define a single field primary key? Single field primary key. Yeah. The answer is no. No means not guaranteed. Okay? Yeah. Sometimes, actually for most of the cases, yes. Yeah. But if there is some special cases that you cannot, so then our answer is no. Okay? Yeah. So no, answer is no, but no means not guaranteed. Okay? Yeah, not guaranteed. Yeah. All right. Why? Yeah. The reason is here, let me draw a simple diagram. Suppose you have a table, okay? Yeah. When you have a table, usually you have multiple columns, right? You have multiple columns. Okay. All right. Then, for each column, it's possible, for each column, the value is not unique. Unique. Okay? For each column, if you only look at the individual column, one by one, none of them has unique values. Okay? That could happen, right? Yeah. Yeah, that could happen. But if you look at them all together, then all those columns, the values from all those columns, they can use to separate different rows, right? Yeah, that could separate different rows. Okay, yeah, all right, yeah, all right, yeah, yeah. So think about this relationship. Think about this relationship. Yeah, all right. Yeah, later I will use an example, concrete example. Yeah, because here, a little abstract. Later I will use a concrete example to help you understand a little better. Yeah. All right, so here, because each column does not have unique value, then you cannot use it as a primary key, right? Primary key, single attribute primary key, it must have the unique values. Otherwise, how can you use it as a primary key, right? Yeah, so that's the answer. The single field primary key is not guaranteed. But how, John?
I'm gonna let you continue. I'm just gonna ask a question later to see if I understand.
Yeah, later I will, when I use a concrete example, yeah, probably, you know, yeah, you're thinking about that concrete example. Yeah, all right. So, single key, single attribute or single field primary key cannot be found in this situation. How about a multi-field combination that could take different values? Yeah. So that's the reason. In that case, you can select more than one fields, appropriate more than one fields, and when you consider the as a tuple, yeah, because when you select more than one fields, you can get a tuple, right? 2 tuple, 3 tuple, and so on. Yeah, okay, yeah, that one. And when you look at the 2 tuple values, 3 tuple values, or higher tuple values, then they have unique values. How about that? That could happen. When that happens, you have an option to define composite primary key. That's the reason why people consider composite primary keys. Okay? Then let me get to the concrete example. Yeah. For the course we are taking, yeah, every semester, yeah, we are familiar with this situation. A course, okay? Yeah. For a course, each course you have a course number, right? Each course you have a number. CS, okay, 4610. That's the course number. Okay? Yeah. Yeah. So here let's consider. Yeah. We want to create a course table. How about that? Suppose we want to create a course table to store all the courses. How about that? Okay? So here, yeah. Concrete example. In the course table, we have a column called course number. Okay? Yeah. Course, yeah. So here, yeah, because I don't have a lot of space, yeah. Let me use short. Course number. One column. Okay? Yeah. Then some courses we may have multi-sections, right? Yeah. So then for those multi-section courses, you need to have a section number, right? You need to have section number, okay? Yeah. One, two, for example, for our algorithm courses, we have 2 or 3 sections sometimes, okay? Sometimes 2 sections, sometimes 3 sections, yeah. So you need to associate with a section number. Yeah, section number. Yeah, section number usually, here, also here, people use 001, 002, 003, and so on. Okay, that's the section numbers. Yeah. Now, in the course table, now you think about it. The course number is not unique, right? Not unique. Yeah, because you have multi-sessions. Yeah, 2 different session of the same course, they have same course number. Okay? Course number is unique. The section number also not unique, right? The section number not unique. Okay? Yeah. Then you cannot use course number as the primary key. You cannot use section number as the primary key. Can you use a pair of course number, section number together to form a unique key?
Yeah, that would cover pretty much all of it.
Yeah, so that's the reason. This time we should use composite primary key. If you want to identify the courses, you need to use both course number and section number. So you group it as a composite primary key. Then you can, so this is a concrete example. You can understand it better. Why we need this concept. Composite primary key concept. Okay? Yeah? Now you can feel much better now. Yeah, because we do not try to understand in an abstract way. Yeah, this is concrete way we understand. Yeah. All right. Yeah, so we complete this question. Yeah. Next question, I need to answer that auto increment. So that one, that idea. Yeah, But that idea, so yeah, I hope I have some space, then I will explain that idea. Okay? Yeah, let me finish this key concept. Yeah. When I find some space, then I explain that auto increment idea. All right. Unique clause. Yeah, very simple. Yeah. If you want to define a key, you need to add a key constraint. So what's key constraint? You need to tell the DBMS for this field, because later we have another composite key situation. So here at the beginning, you can understand a single field key. But later, similar to the situation of the primary key, we need to define composite key. Yeah. All right. Unique class specify alternate secondary keys. Secondary, yeah, primary key, we already have it. Then, other than primary key, you have multiple secondary keys. Then people may ask, why, after you have primary key, why you need secondary keys, right? Yeah. Secondary key later, when we talk about sorting and efficient data search, we need that. We need to use these keys. We need to use these keys. Okay? Yeah. So that in our module 5, we will spend a lot of time to study how to make the data search more efficient. Then we need all these key concepts. Yeah. So here we just define those keys, unique values. Unique clause can also be specified directly for, similar, just take the analogy way. Yeah. Secondary key, if secondary key is a single attribute. Yeah. Example, single attribute key, just append this unique keyword. Yeah. All right, yeah. Or add after, the second way, add after you use this unique clause, okay? Unique clause, after you declare all the fields, then you add this unique clause. Then, think about, you can add a composite key. Inside parentheses, you can use more than one fields. All right, composite key concept. Okay, unique field 1, comma field 2, and so on. Okay, The reason similar to the reason we use to understand the primary composite primary key. All right, Then the third way, the alter table way. All right. Now let me use the space here. I have a lot of space here. Let me explain that. Auto increment type primary key. So let me explain the situation. Situation. John already explained a little bit, but here I need to expand a little bit. So the type of primary key called auto increment. primary key. But here I need to say this is a MySQL feature, okay? For other DBMS, this feature may not be available, okay? It's another, standard, SQL standard. So it's a MySQL feature. Okay? Yeah. For example, in Oracle, it's not available. Okay. Yeah, I know that. In Oracle, it's not available. Auto increment. Yeah. All right. First, because this auto increment, from the name, you can get some information from its name. Yeah. First, it's not original data, original business data, right? Original data does not. So you add one, you add some artificial, yeah. It's not a natural data, okay? So it's artificial data, yeah. Added, yeah, okay, yeah. So not in the original data. Okay, yeah, original data. Yeah. All right, yeah. So, yeah. And so you add it. So this is internal data, okay? For internal purpose, internal usage, not external. External. So what do you mean internal, external? External means we expose the data to our users, right? Internal means we do not expose to our users, okay? Yeah. Our internal people, we have the access. We know it. But external users, they do not have access. Yeah. So we do not show external people internal data, right? Yeah. So it's internal supporting data. Yeah. Internal. Because we need to identify different roles. Yeah. We need to use a primary key to identify different roles. Okay? Yeah. All right. So internal data. Yeah. Okay? Yeah. All right. Yeah. All right. So there, auto increment, yeah, because it's called auto increment, yeah, you declare. So usually the integer value, the first one is 1, second 2, 3, yeah, increment, every time added by 1, yeah, 1 incremental, okay, yeah. Auto, that means you do not need to do it manually, okay, yeah, you do not need to do it manually, all right. After you declare this primary key of this auto increment type. Yeah. Later I will show you the definition. Yeah. Auto increment type, then every time when you add a new row, you do not need to provide us value because the DBMS will automatically generate the value for you. Okay? The first time DBMS use 1, second time use 2, 3, and so on. Auto increment. Okay? Yeah. All right. Yeah. Yeah. Oh, question?
That's automatically increments for like the speed.
For what?
Is it bad to automatically increment up for like speed purposes? Like
Can you
is it
explain?
slower to automatically increment, or is like should we use different keys if we want our database to be able to search queries faster? So I thought it was that.
Different. So you think about search performance, right? Search performance using auto increment key or other keys, right? Yeah. Auto increment key is always the fastest. Yeah. Yeah. So here, yeah, for his question, yeah. So yeah, another knowledge point, let me give it to you. Regarding the search performance, another performance, search performance. performance. Yeah, yeah, yeah. So why I say if you use auto increment based search much faster than any other types. Okay, all right. For our typical fields, here we have numerical values and string values, right? These two types. Numerical values and string value. Okay, all right. String we use alphabetical order, right? Think about, yeah. Numerical we use the natural numerical order, right? It's different, yeah. So here, let me remind you, we use alphabetic order. So now based on this, for numerical comparison, because when you do search, you need to compare numerical values, right? Yeah. For numerical comparison, you only need to do one comparison, because two numbers when you compare, greater, less than, equal, one comparison, you're done. For string comparison, you need to do multiple comparison, character by character, right? You compare first character, second character, third, and so on. So for one string comparison, much slower than numerical comparison. So the result is numerical comparison is always faster than string comparison. Okay? Yeah. Then for numerical values, integer comparison always faster than floating point comparisons. Integer because easier. Okay? The structure-wise easier than floating point comparisons. Yeah. Yeah. So then the auto increment, they are integer numbers. So that's why if you use the that primary key, it should be faster than all other type of keys. Yeah. All right. All right. Yeah. So integer comparison. Yeah. Yeah. So numerical based search faster. Yeah. All right. Yeah. Much faster. Significantly faster. Yeah. Or I need to, look at the time. Yeah. So because I may forget the times. Yeah. Sometimes. Yeah. So you can let me know if I, close to the end. You can let me know. Yeah. 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 Hold it. Yeah. Right now, 10 minutes. 10 minutes. Yeah. Yeah. All right. So let us do one or two slides. Yeah. If we can finish this part C, then it's better. Next time we do part D. Yeah. Constraint, not null, and the default value. Yeah. Not null. Yeah. Yeah. Because if you do not declare this constraint, then you're allowed to use null value. Yeah. Yeah. Remember, sometimes we need a null value. Yeah. Okay. But sometimes you want to do a little better than the null value. Yeah. So you can use default value. Yeah. All right, that's the constraint, not null. Yeah. Where an attribute does not allow the null value, yeah, sometimes you don't want to take the null value. Yeah. All right, so not null. Yeah. All right. All right. So then you need to declare it explicitly. Explicit way. Yeah. All right. There is implicit way. This is explicit way. Okay. Yeah. Implicit way do not need to specify it for a primary key. Yeah. Because the primary key by default, it must be not null. Primary key, you cannot take null value as the primary key, right? Yeah. Yeah. Because of its purpose. Yeah. So you cannot. Yeah. Yeah. So, but you do not need to say it explicitly. Yeah. So by default, it must be not null. Yeah. Primary key. Yeah. Default value. Yeah. Sometimes you like to take some default value. Okay. Yeah. All right. So appending the clause default, then you need to provide a default value. That means if the value is not provided by the user, this default value is used. Yeah, that's straightforward. Yeah. So default value is used in any new tuple, yeah, if an explicit value is not provided for that attribute. Yeah. All right. If no default clause is specified, yeah, then the situation. Without not null constraint, it takes null value. Okay? With not null constraint, insert failure. Yeah. Because if you use the not null constraint, but the user does not provide a value, it's a DBM, so this failure thrown out by the DBMS, we reject it. Yeah. So DBMS will reject it. So it's a failure of insertion. So you need to handle that failure immediately. Okay? Yeah. So yeah, immediately. You cannot delay. Okay. Yeah. If not value is allowed, then you can delay, right? If you do not provide, yeah, fix it later. Yeah. You can put it on hold. Yeah. But sometimes, yeah, you have to solve the problem immediately. Otherwise, this data entry failed. Yeah. Okay. Yeah. So here, that's the meaning. Yeah. All right. Yeah. Good. So we complete this slide. Yeah. Okay. Yeah. Part C. Yeah. All right. Although we have 5 minutes. Yeah. So yeah. Yeah. But it's better not to start a new part. Yeah. Okay. Yeah. So then let me say something about the homework assignments and the midterm. Yeah. All right. Yeah. All right. So you just submit homework assignment number 1. So now we need to do homework assignment number 2. Yeah. For homework assignment number 2, I may like to reduce your workload slightly. Okay. Slightly. Yeah. 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 Reduce your workload. Yeah. So the way I do, yeah, I will create a quiz. Yeah. You need to do the third quiz, right? Yeah. Third quiz. Yeah. Then the homework assignment 2, I will split into part A, part B. Part A, the same as the quiz number 3. So you do not need to do. Yeah, so here, yeah, let me write it explicit. Yeah, I use a few minutes. Yeah, all right. So now you are working on homework assignment number 2. Okay, yeah. I split it as part A and part B. Part A, 10 questions. But 10 questions, we make it the same as quiz 3. Yeah, yeah. So I will give you quiz 3. Yeah, but quiz 3, after you complete it, yeah, the same score will be used as part A of homework assignment number 2. Then you only need to do 15 questions. Okay? Yeah. So instead of 25 questions. Yeah. So in this way, I reduce 10 questions. Yeah. So you can do 10 questions fewer. Yeah. Yeah. Reduce slightly. Yeah. But our main purpose, we need to practice SQL queries, remember? So still, I'll give you 10 SQL questions. So in part B, you have 5 concept questions, 5 concept questions, and 10 query questions. Ten query questions, 5 plus 5. 5 from Northwind database. Okay. Northwind, still, yeah, Northwind. You know, W3 schools, North Wing, and 5 from company. Our own database, company database. Yeah, yeah. All right. Yeah. So in this way, so we slowly, so we will go to the company database. Yeah. Yeah. Still 5 questions from North Wing. So there, you can have some hands-on experience. Yeah. Hands-on experience. Okay. Yeah. So there, I hope you get our exam installed successfully. Yeah. Because, or some students you may use like MySQL SQL Workbench. Yeah. So another commonly used tool, a SQL Workbench. Yeah, many students use that. If you have that, that's okay. You can use that Workbench to run your SQL query experiments, testing. Okay? Yeah. So then, if you can install XAMPP successfully, yeah, XAMPP, double P, okay, successfully, yeah, then you can install the company database. Then you can also have some hands-on practice. Yeah. So give you some time to install. Yeah. It's not hard, but for some students it may take some time. Okay, especially for Mac students. For PC students, always very smooth. Yeah, no problem. But for Mac students, so there's a small percentage, 20 something percentage, so Mac students may have some problem. Yeah. All right, that's it. Yeah. So we finish part C here. Yeah.